Hi, my name is James Huang, and I will be presenting Scala, which is a multi-paradigm programming language to you guys. We'll just start with a brief overview. So, Scala is a multi-paradigm programming language. This means that it supports both functional and object-oriented design. It can use Java libraries, so it can use scanner, it can use file, it really can use almost anything in Java. There's a strong static typecasting. This allows Scala to be very generic. It's kind of along the same lines as C Sharp. So why should we choose Scala? The most important question. It's a multi-paradigm language, so we can solve problems the way that we want. This means that we can use functional programming when it's appropriate, or we can use object-oriented programming when it's appropriate. And this actually produces a lot more efficient and shorter code for the programmer. Another reason to use Scala is that the developers listened. Scala overcomes the shortcomings of Java, and one example of this is something that I talked about earlier. It's the strong static typecasting. So Scala is a lot more generic than Java is. Scala also can solve the same problems as Java, but with less lines of code, which saves the programmer a lot of time. And we all know that's important. So let's get started with the demo. So I have here two files. One is the functional approach to solving the problem, and one is the object-oriented approach. I'm using the rainfall midway.txt file from the homework that we saw. And the problem that I'm solving is I'm trying to print the average rain by year. So we're all familiar with this problem, so we don't have to think about how to solve it as much. But I'll walk you through the code. So here is a method in Scala. It's reading the file in. And here is another method where we're parsing the lines. So we're converting the list of strings that we got from read file to a list of doubles that we got from parseLine. And one thing to note is that we do have high order functions, so our favorite from F# map is actually still available in Scala. And then we have the actual method where we're printing the average rain by a year. So it prints the year and it changes it to an integer so it doesn't have a 0.0, and then it prints the average of that year, and it's formatted with this. So let's go ahead and run it. Alright, so that's the output. And now we'll switch over to the object-oriented design. So with the object-oriented design, I tried to follow a more Java-like approach to solving this problem. I created a class here, and one thing to note in Scala is that they do not use constructors. They actually make the method call itself a constructor. So I have YC and AC, which I am initializing year and average rain to. And then I have these functions here that set the year and set the rain. Here I have to initialize the object. As we all know, we have to allocate memory for any objects that we use. So here is where I am doing that, and it looks kind of Java-esque. The syntax is obviously a little different. When I'm reading the file, I am creating an array of strings again, but I'm actually importing Java methods to do this, or Java types as well. One of them is file, so I am importing file, which opens the file name and stores it in file open, and then I'm using the scanner sc to open that file. And here I'm just iterating through and grabbing every line, and then I'm returning it as an array of strings. Afterwards, I'm parsing by year, so I am storing the year, which is the head of this array right here, and I'm storing that in year string, and then I'm parsing it as an integer and setting it in set year. For parse average rain, I actually did use a high order function, but I am just adding up all the values after the head and converting them to a double, and then I'm setting them in as the average in set rain. So, as you can see, the object-oriented code is much longer than the functional approach. The functional approach is a lot more elegant. And this is like a perfect example of when we can just use functional programming as opposed to object-oriented programming to solve something. So I'm going to go ahead and run the code, and it should give us the same output. And it does. So both methods work. So one thing that we want to know is, how does Scala implement both functional and object-oriented language, or object-oriented design? So in Scala, all functions are objects. This means that all methods have values. We saw this. Every single method that I had inside of my demo had a return type. There is a generic return type in Scala. It's called unit, and that's I believe that F# also had something that was kind of similar to that. There are immutable objects in Scala, so this is the difference between val versus var. Val is a value, so you can only assign a value one time, so that's the immutable one. And var is a variable, so it can be assigned multiple times, so that's mutable. There are high order functions in Scala. As you saw, we had our map function, which is a favorite of mine. And now let's talk about how Scala is object-oriented. So in Scala, everything is treated as an object, and everything is implemented in classes. So data types are implemented in classes. As you can see in this hierarchy tree, we have a parent class to everything any, and then we have a subclass anyval and a subclass anyref. Anyval is our data types, so we see there's double, float, long, and short. And anyref is our objects that you'd think of in Java or C++. So some examples of this is Scala object, string, list, sequence. Everything is implemented in a class. So every operation has a method call. So when we're actually doing x plus y, you'll remember that x is an object, so it would belong here. Plus is our operator, which is actually a method, and y would be our second object that would be passed as a parameter to this method call. So there are criticisms of Scala, just like there are criticisms of every language. It has a steep learning curve. A lot of people say that Scala is really hard to learn because you have to switch gears from functional and object-oriented programming. It's hard to read, and part of this is due to that you can mix Java and Scala, and also part of it is also due to how you can do functional and object-oriented programming at the same time. There's extremely long compile times for Scala. As you kind of saw earlier, it takes about like 3 or 4 seconds to compile code that was relatively short. So this problem becomes larger with longer pieces of code. But what I'd really encourage you to do is figure out for yourself, because I am enthusiastic about Scala. I think it's really cool that you can solve problems the way that you want, or use a mix of functional and object-oriented to solve problems. it really gives you the choice to do what you want to do. And that's pretty cool from an academic viewpoint. So try it yourself, and that's concludes my presentation of Scala. These are my references, and thank you for watching.